All right, so in this question, we read that Mildred is working with a number of sequences shown. So 2, 5, 7, 12, 19, 31, 50. If the sequence continues this pattern, what will the next number be? Now, to be fair, it turns out there's a really good reason to argue that it could be any number you want, but there is a specific pattern that they're trying to build here that's more obvious than the others. I think that one is, if you look at it, 2 and 5 give you 7, 5 and 7 give you 12, 7 and 12 give you 19, so on. And so we add two numbers together to get the next number. So if that's the case, to get the next number, I simply have to add 31 and 50 to get 81. Then we read here that Mildred believes that she sees a pattern in the sequence for determining which numbers will be prime. Seeing that there are three primes followed by one composite, then two primes followed by two composites, she makes the conjecture that the sequence will continue with one prime followed by three composites before another prime. So which of the following numbers down here is a counterexample? Well, let's just take a quick look at this. So what we've got here, the pattern that we've got is prime, 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 composite, prime, prime, and then we've got composite. Now if we keep going, I've got another composite here, and then I have a prime, 131. If I add those together, I get 131. And then if I add those together, I am going to get a composite. I'm going to get another composite. When I add those together, I'm going to get another composite. And now this one, according to her conjecture, before another prime shows up, so we've had our three composites, the next one should be prime. But it turns out that 898 is not prime. It is composite. It's divisible by 2. So 898 is going to be the exception or the counterexample to that conjecture. Now let's take a look at what else she did with this. Mildred also divides each number in the sequence by the previous number as she moves down the list. She makes a conjecture that the quotient approaches a single number. To the nearest hundredth, the number the quotient approaches is. Okay, so what we're going to do here is just start dividing out term after term. Now, after a little while here, you're going to start to notice that you do get a bit of a pattern here. If you take 212 and divide it by 131, you're going to get 1.6183 ... If I go 55 divided by 343, just move over a little bit, I'm going to get 1.61807 ... 898 divided by divided by 555 is going to be 1.6180 ... So I think it's pretty clear. It is approaching a number here. In fact, there is it's a very special number, and I'll let you look that up on your own later on here, but it's a very special number. And if we round that to the nearest hundredth, it's 1.62.